And insurers' reimbursements have PDF proportional to XE negative X squared for X between 0 and 1. Calculate the mod. And since it's proportional to XE negative X squared, it means it's equal to C XE negative X squared, where C is a constant. And again, remember in the problem, they also said that it's 0 elsewhere, but we have made the convention that whenever we define it whenever we define a PDF in a certain region, it's understood that it's 0 elsewhere. So we don't have to say it. So mode is the X value at which Fx is maximum. So recall from calculus that the absolute max and min are found by evaluating the function value at the endpoints and at the critical points. So here the endpoints are not included because the inequalities are strict. So we only have to look at the critical points, and critical points are those where the derivative is 0 or undefined. So let's take the derivative. C can be pulled out and then apply product rule on x and e to the negative x squared. So derivative of x is 1, and you keep the e to the negative x squared plus, and then you keep the x. You take the derivative of e to the negative x squared, which is e to the negative x squared times negative 2x. And then I can pull out the e to the negative x squared. So I'm left with a 1 from here, and here it's x times negative 2x, which is negative 2x squared. So this is never undefined, obviously. And the only thing we have to worry about is the points where it's 0. So when we set it equal to 0, we see that the C can never be 0, because if C appears in a product of a PDF, then C being 0 will mean that the PDF is always 0, which is never possible. And also we know that any exponential function is never 0. So this factor is never 0. So it means that when you set the whole thing equal to 0, then the 1 minus 2x squared will equal to 0. So this gives you x squared equals half and x equals 0.71. We only consider the positive root because x is between 0 and 1. And that was choice C.